Hello everyone, I am Shampasari and welcome to Asian Academy. So as you can see from the title of this video, in this video we'll solve another question on the topic of geometry, and the question is as follows. Two cubes of edge 2 units and 1 unit are kept side by side as shown in the figure. A wooden plate just covering both the cubes and touching them on the edges is placed such that it rests on the wall as well as floor. 3 balls are kept in free space touching the cube, wall, floor and wooden plate. Find the ratio of radii of balls 1, 2 and 3. Now we are provided 4 options for this question. Option A 3:2:2, option B 2:1:1, option C 4:3:3 and option D 8:1:1. So this was our question on the topic of geometry, and I would like you to try this question first by yourself and then come to this video for the solution. I hope that I've tried the question and you've got the solution, and if you didn't, then let's check the solution. So according to our given question, we are given to find the ratio of the radii of these 3 balls such that this is a wall, this is a ground, this is the wooden plate that touches the balls, the cubes and the floor. Now to calculate the radii of this first, second and third ball respectively, what we have to do is we have to first find the sides of the triangle, and then we can use the formula for finding the inradius for a right angle triangle, because basically these balls are inscribed in 3 right angle triangles of different or same size maybe that we'll find after solving the question. So according to our given question, the bigger cube is of 2 units. So this distance till here is equal to 2 units. This distance is equal to 2. The smaller cube is 1 unit, so this is 1, this is 1, this is 1 and this is 1, and since the edge of the cube is 2, so 1 plus 1 is equal to 2, so this is also 1 and this is 2. Now these are the given distances. Now we have to find the remaining distances to apply the formula. Now we can first name the triangle's vertices. So if this is A, this is B, this is C, and let's name these vertices as D, E, F, G, H and I respectively. Now why we have named the vertices? Because to solve this problem we have to apply the properties of similarity, because otherwise this question will be very complicated, and to solve this question by the help of similarity, then we will use the formula. So let's solve the question with similarity. Now if we look in the triangles EFG and EHC, we can say that angle E is equal to angle E because it is common in both the triangles, and we can say that angle F is equal to angle H because it is 90 degree in both the triangles. So we can say that both the triangles EFG and EHC are similar to each other by AA axiom of similarity. Now when two triangles are similar to each other, their corresponding sides are in the similar ratio. So we can say that EF by EH is equal to FG by HC, which is further equal to EG by EC. Now we just have to put the respective values and we'll get the answer. Now what we can do is we can name the remaining sides for our answer to be more simpler. So we can say that AD is equal to Z, A is equal to W, IC is equal to Y, and we can say that GC is equal to X. Now we have got EF by EH, so we have got as 1:2, FG by HC is equal to 1 by 1 plus Y, and EG by EC is equal to root 2 by root 2 plus X. Now how EG is equal to root 2? Because if this is 1 and this is 1 and this is a right angle triangle, so we can say that Pythagoras theorem on EFG is equal to 1 square plus 1 square is equal to EG square. So we can say that EG is equal to root 2. Now if this is root 2, then this is equal to root 2 plus x. So we have got the value of y as 1 and the value of x as root 2. By proving these two triangles similar, we have got two values x and y, and let's find out the values of z and w by again using the similarity on two different triangles. So as we have got the values of x and y as root 2 and 1 respectively, we have replaced them, and now let's find the values of z and y. Now again using the similarity in the triangles ADE and the triangles ABC, we can say that angle A is equal to angle A because it is common in both the triangles. and we can say that angle D is equal to angle B, which is equal to 90 degree. So we have got these two triangles similar again by the AA axiom of similarity. Now to find the values of Z and W, we can again use the property of similarity that when two triangles are similar, their corresponding sides are in ratio. So we can say that Z by Z plus 2 is equal to 2 by 4 because 2 plus 1 plus 1 is equal to 4 since BC is equal to 4. So we have got 2 by 4 which is further equal to W by W plus 2 root 2. So this is our corresponding sides ratio. Now from this we have got the value of Z as 2 because Z by Z plus 2 is equal to 1 by 2. So we have got the value of Z as 2, and if we solve this, we have got 1 by 2 is equal to W by W plus 2 root 2, and if we solve it, we'll get the value of W as 2 root 2. So from here we have got the value of Z as 2 and the value of W as 2 root 2. So we have got the values of all the remaining parts, and now let's apply the simple formula for the inradius of a right angle triangle, and then we have to simply find the ratio. So according to our last step, we have got the values for all the sides of the triangle, and let's find the radius of all these three circles and then find the ratio. So according to our given question, this circle was radius 1, this circle was radius 2, and this circle was radius 3. So basically we have to find R1 is to R2 is to R3. Now we know that inradius for any right angle triangle is equal to S minus H, where S is the semi-perimeter and H is the hypotenuse. So R1 is equal to 2 plus 2 plus 2 root 2 whole divided by 2 minus H, that is equal to 2 root 2. Now upon calculation, this value will come as 2 minus root 2. So we have got the value of R1 as 2 minus root 2. Now if we calculate the value of R2, then it is equal to 1 plus 1 plus root 2 whole divided by 2 minus root 2. Now if we calculate this value, this is equal to 2 minus root 2 whole divided by 2. Now we don't have to calculate the value of R3 because R2 and R3 are basically same triangles with the sides 1, 1 and root 2. So the R2 and R3 will be equal. So you have got R3 also as 2 minus root 2 whole divided by 2. Now if you notice carefully, if R1 is equal to 2 minus root 2 and if we consider it as small a, then R2 and R3 is basically equal to a by 2 and a by 2. So the ratio of a by 2 and a by 2 is simply equal to 2 is to 1 is to 1, which is option number B according to our given question. So the ratio of the radiuses of these three circles are in 2 is to 1 is to 1.
That was all for this video, and I hope that you understood all the topics covered in this video. And if you have any doubt, then you can post your doubts down in the comment section, or you can send your doubts to us to our channel's official Instagram or Facebook page, and we will surely solve your doubt as soon as possible. Or you can go to the official website of ACN Academy and you can send your doubts to us from there, and all the links are provided down in the description. And if you did like the video, then please hit the like button and subscribe to the channel ACN Academy.